Okay, so in terms of trig equations, we have cosine and sine, and the way we're gonna start is the values of cosine and sine in on a 45-degree angle, so on 90 degrees or 0 degrees or 180 or 270 degrees, or so the unit circle is basically a circle with a radius of 1. That's why the ratios are just pi over 3 and 1 instead of x and pi over 3, it appears in most websites. So in terms of coordinates, this point over here especially, that's gonna be, this is going to be the x, and this is going to be a y, so this is going to be 1 and 0, because this is x and y, right? And the representation of cosine and sine is, it's cosine is x, and sine is y. So in this case, at 0 degrees, cosine would be 1 and sine is 0. And this because x is 1 and y is 0. Here, x is 0, so cosine 0, y is 1, so sine is 1. The same thing, but here it has to be negative, and this one has to be negative cosine over here, and this has to be negative sine because it's a negative 1. So that's basically what you need to know for questions such as like this. Cosine 0 equals let's see, x. Now because it's 0 degrees, so cosine, that's going to equal 1. And let's see, sine pi over 2, that's going to equal 1. And cosine pi over 2 is going to equal 0, basically. So that's the thing you need to memorize, that it's x is cosine and y is sine, for you to solve like those types of equations. Now in terms of tangent, of course, we'll look at a graph later, but tangent is basically, tangent is the opposite over hypotenuse, or sine over cosine, right? So so if they ask you for the tangent at 0 degrees, for example, it's going to be sine is 0 and cosine is 1, so it's going to be 0 divided by 1, that's 0. Now we'll look at, I said before, we'll look at the graph later, because if we were to put tangent at pi over 2, let's say, so here it's gonna be 1 over 0, which is undefined, so that value does not exist, but we're gonna look at that later. For now, we'll solve basic trig equations, and we're going to start with the way the quadrants are and what you need to know before you start solving. So we all know sine equals opposite over hypotenuse, right? And cosine, it's adjacent over hypotenuse. So given this, that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, we can discover like when the trig function is going to be negative or it's going to be positive in the unit circle. So a sine is opposite and hypotenuse. If we have if they ask us for the sine of an angle here, so either pi over 3, pi over 4, pi over 6, The sign on the hypotenuse doesn't matter, so it doesn't really matter. It's always going to be, it's not gonna influence the sign. But here we see the y value is positive, so sine is gonna be positive in the quadrant 1. Cosine is also going to be positive because the x component is also positive. Now we know tangent is opposite over adjacent. Opposite over adjacent. So the opposite is positive, the adjacent is positive, so it's going to be positive as well on quadrant 1. So that's all going to be positive. We're going to put it all. We're going to put an A for all. Just know what that means. Now if we get an angle here, sine is opposite over hypotenuse, so sine is still positive because the y value is still positive. The opposite, so this is still positive because it's going up and it's not positive, so sine is also going to be positive on the second quadrant. Now cosine here is going to be negative because it's, so this is 0, this is -1, and it's going to moving on the negative direction. It's in the negative part of it's on the negative part of the y-axis, so it's going to be negative. So that means positive, negative, tangent. A positive and a negative is negative, so here only sine is positive. We're to make an angle here. Cosine is also negative because it's on the negative part of the y-axis, like on the negative side. But sine is also negative because the opposite, it's also negative because it's below 0. It's -1. It's on below the 0 line, which means it's negative. So sine and cosine are negative. Now negative and negative is positive, so tangent is going to be positive. So here tangent is positive, everything else is negative, and here sine is going to be negative because it's below, it's going down. Cosine, which is adjacent, so it's going to be positive because it's on the positive side of the x-axis. But so because it's negative and positive, tangent is going to be negative, so cosine is the only positive on the fourth quadrant. And a good way to memorize that, they teach it a lot, is let's write it here: all students take calculus. So that's a good way to memorize it. So this is quadrant 1, this is quadrant 2, this is 3, and this would be 4. So all for the A, it's going to be all for all of the functions. So sine, cosine, and tangent are positive. On the second quadrant, it is S. Only sine is positive, so S of students. On the third quadrant, T is positive, so T of take. And on the fourth quadrant, C for calculus. Only cosine is positive. So that's a good way to memorize the negative and positive on each quadrant. So now we'll move on to actually solving some problems and understanding more about the unit circle, and doing some graphs to prepare you for more for what we're really looking towards and what basically calculus is all about. Okay, so now we're gonna solve some problems. Just pretty basic ones that you're gonna find pretty much everywhere. If in pretty much everywhere, yeah, I would say. So let's start with simple ones. Let's say it's sine. Now there's two types of problems, of course. So there's one where you have to find what the y value of, like, let's see here, y equals sine pi over 3. So you have to find the y value, right? And here it's gonna be related to graphs that we're gonna get on later. That's where you're gonna find your trig ratios. So sine at an angle of pi equals 3. Now the first thing you gotta identify is what angle, what special triangle am I looking at here? So pi over 3, that's the same as 60 degrees if you recall. And the next thing you gotta look at is the trig symbol, so sine. So we know sine is opposite of hypotenuse, and this is where you gotta know your ratios. We know the opposite of sine is always going to be square root of 3. Now, in a 60-degree triangle where we have a right angle, there's always going to be a 30-degree angle at the opposite, right? So we know that on a 60, 30, 90, the opposite of 60 is square root of 3, but the opposite of 30 is 1. And the hypotenuse is going to be 2. Now sine is opposite hypotenuse, so if the opposite is square root of 3, the hypotenuse is 2. That's gonna be our value for y equals sine pi over 3. That's y is gonna equal square root of 3 over 2. That's gonna be our value. But this is where we gotta look at it. If it's sine followed by an angle, if it's sine and it's enclosed and it's followed by a angle, or you're gonna have to find the ratios as I did here. Now let's do another one. So let's do y equals cosine. Let's do it on another quadrant. Let's say 5 pi over 4. This is where you gotta know your ratios, okay? Your and your angles at all 4 quadrants. So cosine 5 pi over 4. We know it's over 4, so it's gotta be a 45-degree angle, which we have here. Okay? So we know the ratios are 1 to 1 and square root of 2 from first part of this lesson on special triangles. So it's gonna be a 45, 90 triangle, special triangle. Now we look at cosine, right? So it's cosine followed by the angle, or followed by parentheses, and the number side is an angle. So cosine is adjacent over hypotenuse. So the adjacent of 45 is going to be 1. The hypotenuse is going to be square root of 2. Now this answer depends on your lesson, but sometimes they require you to rationalize. So you just rationalize, take the square root out of the denominator, and the way we do it is we multiply by the value of the denominator. So in this case it's square root of 2. So by doing this, the square root cancel. So that basically is gonna equal square root of 2 over 2. And that's basically gonna be our rationalized answer for y equals cosine 5 pi over 4. Now, don't remember, all students take calculus, right? So all students take calculus. So we know that sine is positive, so cosine is not sine. Cosine must be negative. So and that works because cosine is adjacent, and the adjacent is this x component over here, so it is negative. So actually the answer is negative square root 2 over 2. So be careful with the negative. It's really important that you don't miss that, and especially because it's 5 pi over 4. Actually 5 pi over 4, so that's 1 more than 4 pi over 4. So it's gonna be 1 more than 5 pi over 4, so it's actually gonna be here. So the tangent's only the positive one, so its cosine is still negative, so it's gonna be here. That's 5 pi over 4, and that's how you work with the unit circle to find this equations, basically. So you add 5 pi over 4, you know 4 pi over 4 is pi, so it's 1 more, so that's how we can find the quadrant that it's in, basically. Now let's do a couple more with tangent values, and it's all should be reviewed, so this is just like a refresher. If you want more examples, you can comment, and I'll post some practice for you to do. But let's see y equals tangent. Tangent's a bit different, so we do y equals tangent. Let's do 7 pi over. So let's do, what do we want to do? 7 pi over. No, we'll do here. Pi over 6. That is pi, so we'll do pi over 6. So now tangent is going to be, so our first step is to recognize what the problem is asking here. So it's tangent followed by it's going to be followed frequently in parentheses, followed by an angle. So we know we have to find tangent, which is opposite over hypotenuse, and the ratio at that angle. We know pi over 6 is the same as 30 degrees, because 30 fits 6 times in 180 degrees, which is pi. So we will look at our 30 degrees on a 30-60 triangle, and we know the opposite of 30 is 1, so it's going to be 1, and the adjacent is, remember, 30, if there's a right angle, the other one's going to be 60, because all of the angles inside a triangle must add up to 180 degrees. So the opposite of 60 is square root of 3, right? So it's going to be adjacent to 30 degrees, it's going to be square root of 3. So that's going to be our answer. Now, we got to look at now the sign. So we know tangent is opposite and adjacent. Opposite, in this case, it's here. So we know this is positive. Adjacent is here. So we know it's positive. So it's positive. And now we rationalize, so we take out the square root out of the denominator. So we multiply by the value of the denominator, or over the value of the denominator. And the reason we can do that is because it's the same as multiplying by 1. So just square root of 3 over square root of 3. Now this is the same as 1. So we can actually multiply by that to take out the square root, and it's going to be square root of 3 over 3, and that's going to be our answer. So that's how you work. Those are some examples. In terms of so let's do some examples to find the y value with an angle. Let's do some inverse equations. Okay, I'm sure you know we have cosecant and secant and cotangent. Now it's important to know what cosecant, secant, and cotangent are. They're basically the inverse of sine, cosine, and tangent. Okay, so the way to memorize it is cotangent. It's pretty self-explanatory. Is the inverse of tangent. Cosecant and secant, that's where you can get a little bit messed up. So the way is you just take cosecant, right? So it's gonna be, if it's cosecant, it's gonna be sine, and if it's secant, it's gonna be, oh, that's not an equal sign, that's just an inverse. It's gonna be cosine. So it's kind of the opposite way of where they're gonna start. So when you look at cosecant, as cosecant and cosine have they're not the inverse of each other. So if it's cosecant, its inverse is sine. If it's secant, which is the same as at the start of sine, secant and sine, then they're not the inverse of each other. So secant and cosine are inverses. That's how I remember. So cosecant similar to cosine, so they are not inverses. So cosecant must be the inverse of sine. Secant is similar to sine, so they are not inverse of each other. So secant must be the inverse of cosine. Now this is key. You have to memorize this. So let's just do some equations with that. We have y equals cosecant pi over, pi over let's do third quadrant. Okay, let's do 7 pi over 6. So that's cosecant, if it's not clear enough. So we know cosecant, it's just the inverse, right? So we take sine, which is opposite over hypotenuse, and we just flip it because it's the inverse now. So cosecant is hypotenuse over opposite, and that's how it works basically. So now we know it's cosecant, so it must be the inverse of sine. Now we have to find the angle, 7 pi over 6. So we know it's over 6. That means it must be a 30-degree angle, because 30 degrees fits 6 times on 180. That's why it's important to memorize your 30, 60, and 45-degree angle in radians. And so after you recognize all of that, you find where your angle is. So it's 7 pi over 6. That means 1 more than 6 pi over 6. We know 6 pi is pi, so it must be, so this is 6 pi over 6. So it must be 1 more than that, so it must be here on the third quadrant. So we know it's a 30-degree, and it's asking us for the cosecant, so the inverse of sine, that means the hypotenuse over the opposite. So we know the hypotenuse of a 30, 60-degree angle, it's going to be 2, and the opposite of a 30-degree is 1. So this is going to be 2. Now remember, cosecant is the inverse of sine. That does not change the sign. the negative sign at all. That's not the opposite is gonna be negative right here, so it's still a negative value, because remember, all students take calculus, so only 10 is positive, so it is going to be negative 2. Where sine is negative, cosecant is going to be negative. Where cosine is negative, secant is going to be negative. Now let's look at cotangent. So cotangent especially, we're going to do two types of cotangent problems. Cotangent is the opposite of tangent, so it's going to equal adjacent over opposite. And it's basically the same as sine and cosine. You just need to know that the only thing that switches is your 0 and 90 and 180 degree values. So if we do y equals tangent, cotangent, I'm going to do two examples with cotangent. Cotangent pi over 3. So we know pi over 3 is a 60 degree angle. So we know cotangent is adjacent over hypotenuse. So the adjacent of a pi over 3 of 60, the adjacent is 1, and the opposite of it's square root of 3. Now we know it's pi over 3, so it must be in the first quadrant. So it is positive, because everything is positive on the first quadrant. And now we rationalize it, which we all know how to do. Now let's take a look at y equals cotangent. Let's do y equals cotangent 0. So cotangent, we know it's 0 degrees, and we know cotangent is adjacent over hypotenuse, same as here. Now this is where you need to know your unit circle and what it represents. So we also know cotangent is the square root of tangent, right? And tangent is sine over cosine. So cotangent must be cosine over sine. So remember what cosine is when it's 0. Let's take a look back here. So cosine, remember this, 1x, 0y. And we know that cosine is x, y is sine, so cosine is 1 and y is 0. So it's going to be 1 over 0. Now over 0, you can't divide over 0, so this is going to be equal undefined. So you gotta be careful with, you gotta know in that terms, you gotta know what is what in terms of pi and in terms of sine and cosine. Now it's very similar for y equals sine problem. So let's do y equals sine, and then let's do pi over 2, and that's gonna equal, we know sine is 1 here. It's gonna equal 0. This is 0, 1. So we know x is cosine, y is sine, so that's going to equal 1. Now there are other types of problems that you're going to be asked. So it's not going to be about finding the ratios, it's going to be finding the angle. So it's often going to go like this: sine x equals, let's do 3 pi over 2. Now, what you gotta do here is that you gotta solve for x. So it's the same as algebra, but what you do here is by taking the inverse of sine. The inverse of sine is not cosecant, but it's gonna be, well, it could be cosecant. No, it is cosecant. But in terms of this, we actually want to put it as arctan, or arcsine, sorry. So it's gonna be sine minus 1. That's the same as cosecant, right? But we're just gonna put it as sine negative 1, which is the same as arcsine, and that's gonna equal x. Sorry, that's gonna equal 3 over 2. So what we did here is just multiply sine on each side to solve for x. So we multiplied sine to 3 over 2, which is what we get here, and sine and arcsine cancel out. So we're left with x equals arcsine 3 square root of 3 over 2. Now this is where we're gonna know the ratios. So we know sine is opposite over hypotenuse. So we gotta know that we gotta know the angle that's opposite to square root of 3. Now if we look at our triangles, we know opposite of square root of 3 is 60. So this is a 60-degree angle because it's opposite over hypotenuse, and the hypotenuse is 2. So it's the opposite of square root of 3, which is 60. That means our angle is going to be pi over 3. And that's basically how it goes for in terms of when you gotta solve for an angle. So you gotta identify two things: if it's solving for an angle or if it's solving for a ratio. If you have to solve for a ratio, you find the angle, what its corresponding special triangle is, what's opposite to the angle, what's adjacent, and you get your ratio. And if you gotta find a ratio, an angle, you just take the ratio and see which angle is correspondent to that ratio, just how we did here. So now we're gonna look at a little bit of applications, if you want. I'm gonna do a vector. So this is gonna be a really quick vector addition. It's gonna be a thing you actually do a lot of in physics and math. Eventually, you're gonna have to divide stuff into different vectors, and this is kind of to tell you where a lot of equations come from. So if we have a let's say velocity equals 5. But no, let's say a force, because you're gonna force. It's gonna equals 5 newtons. Just don't worry about it. And it's gonna be diagonally, right? Often you're gonna have to divide it into x and y components. So this is x and y. And just put arrows here, so it's going to be down and up. So to find those components, you got to look at the equations related to this angle with the horizontal. So if we want to find the x component, we need to find the adjacent adjacent side of the angle. So we're gonna use cosine, because cosine is adjacent over hypotenuse, right? And we have the hypotenuse, we have 5. So how do we to solve for adjacent? It's the same as algebra. So if this is dividing, we multiply by h on both sides. The way I like to think is just you just carry this over here and multiply it because it's dividing, right? And so this actually cancels. I'm gonna have, let's rewrite it. H cosine x equals adjacent. Now this angle is almost always going to be given, so you just plug into the calculator and solve for it. Now if this if this angle is let's say 60 degrees, let's say x is 60 degrees, and remember you could just have you can't just have h cosine equals a. If again always next to cosine or sine or tangent, because there's gotta be an angle next to arctan or arcsine or arccosine, which is what we did here. So next to arcsine, there's gotta be a ratio. Just remember that. So let's say it's 60, right? Cosine 60, we know cosine 60 is the ratio basically. So what's adjacent to 60? Adjacent to 60 is going to be square root. It's going to be 1, because that's the same as pi over 3. So it's going to be 1, and opposite to it, it's going to be square root of 3. So eventually, the adjacent is going to equal h over square root of 3. And that's how you solve for your x component. And you do the same for your y component, but because it's opposite to the angle, you're going to use sine. And so that's basically where it comes from. Vectors, all these equations, you always similar equations, and in terms of it's useful for projectile motion and for forces and momentum, because momentum's always it's always going to be in terms of x and y. So that's where it comes from.